Good morning. I'm Dr. Cynthia, Professor, Department of CSE from Kumaraguru College of Technology. Today let's see about 4G network, commonly known as LTE, which is long-term evolution. Let's see how 4G differs from 3G. We have already seen about 3G network. The major characteristic of it is voice and data are considered independently, whereas in 4G it is converged data. All types of data are converged as single data that can be transferred through IP. It handles voice data, text data, multimedia data and so on. The network architecture in 3G is cell based, whereas in 4G it is different types of wireless and wired network. The frequency band in 3G, it ranges from 1.6 to 2.5 gigahertz, and in 4G it is 2 to 8 gigahertz. If you see the bandwidth in 3G, it is 5 to 20 megahertz, and in 4G it is over 100 megahertz. And if you see the data rate in 4G, it is huge, 20 to 100 Mbps when compared to up to 2 Mbps in case of 3G network. The access method in 3G, it was CDMA, whereas in 4G, it is either MCCDMA or OFDM, which is orthogonal frequency division multiplexing. This is the technique which is also used in 5G network. When you take switching technique in 3G, it can be either circuit switching or packet switching. In 4G, as it is through IP network, it is exclusively packet switching. And considering about IP version, 3G supports multiple versions, whereas 4G also supports multiple versions and also IPv6. The special features of 4G network. As we have seen, it supports interactive multimedia, voice, video, wireless internet and other broadband services. 4G provides high speed, it has high data rate, high capacity, and also the cost per bit is very low. And 4G provides global mobility. You move from one country to another country, you can even have service portability. Whereas now if you go to a different country, you have to get their own SIM card, and then you have to register with their own service provider. So here it is scalable mobile network. 4G provides seamless switching, variety of services, especially with QoS requirement. QoS requirement, you can have support services that need high throughput or low delay or high reliability. It provides better scheduling and call admission control techniques. This includes ad hoc networks and multi-hop networks. It provides services for different types of networks. Let's see about elements of 4G LTE architecture. As you can see, the right side, it is the LTE architecture. So you can see here various components of 4G architecture. Let us see it one by one. First one is the mobile device. So mobile device, here it can be any type of mobile device starting from your smartphone, tablet, laptop or any type of IoT device. So any device which will usually have a SIM card with an IMSI number. Here the terminology we use is user equipment to refer to a mobile device. So mobile device or user equipment is the primary component. The next component is the base station, what we normally call in case of 3G network. So those are the mobile towers which are located in different locations. So a single geographic location can have a single base station or multiple base station based upon the size of the cell and the density of the subscribers or users. So here it is the base station will coordinate the mobile device or user equipment authentication with all other elements. So it is somewhat similar to our Wi-Fi access points, and it is commonly called as eNode B. So henceforth in 4G network we will be calling the base station as eNode B. So here the next component we are going to see is home subscriber service. So we have already seen there is a user equipment, there is a eNode B. E stands for extended node. When we specify the term node, that means it is part of the network, and B stands for base station. So eNode B is the extended node base station. So next is the home subscriber service. So this home subscriber service, it is provided in every home network. So this will store the information about mobile device for which the home subscriber service network is the home network. So this is the HLR what we had in the 3G network. So it works with the mobility management entity. So the primary job of home subscriber service is to maintain the details of the user equipment. You can see in the diagram below. Here there are multiple user equipments, there are multiple eNode B stations, and say we are going to communicate between a particular user equipment and a distant server, say for some internet service. So you need to send the information. So for that the user equipment will first communicate with this home subscriber service to check whether it is authenticated, whether it has paid the bill, whether it has subscribed to certain services. So only after that it can proceed. Let's see mobility in 4G network. So it is the major task of this mobility management entity to handle this mobility and as well as the handover. As a first step, it is the base station association. The user equipment will associate itself with the base station and will provide its own details such as IMSI number which is present in the SIM card. The second step is the control plane configuration. So here the mobility management entity will register these details of the user equipment with the home subscriber server. The home subscriber server is the HLR which is present in the 3G network. So all details of the user equipment, the type of service he has subscribed to, whether he has paid the bill or not, etc. will be stored in this HSS. The third step is the data plane configuration. So for final forwarding of the data which is in the home network must be handed over to the user equipment wherever it is present. So from this PGW of the home network to SGW of the visitor network, a tunnel is formed for transfer of this data, and data is transferred, and there is seamless handover of the mobile device. The next component we are going to see is SGW and PGW. PGW is the packet gateway and SGW is the serving gateway. So as we have seen, our ultimate motive is for the user equipment is to communicate with the server, say for which it is communicating along the IP network. So for handling this service, we need this packet gateway. So this is the gateway between the cellular network and the IP network to connect the user equipment with the distant server. So is this single packet gateway capable of catering to all the user equipment? Definitely it is a high load. So for that we are having multiple serving gateway which will serve this function of enabling this user equipment to communicate with the distant server. So how many SGW or serving gateway we need? It depends upon the number of user equipment and number of eNode B. So you have a packet gateway. In order to support this packet gateway, we do have multiple serving gateways. So this will serve the connection between the user equipment and the distant server. The next equipment we are going to see is mobility management entity. As the name indicates, the mobility management entity deals with the mobility of the devices. So as we know, in case of mobile network, a mobile device keeps moving. It either moves within a cell or from one cell to another cell. So wherever it moves, the service has to be provided, and there must be continuous handoff, as in we have seen in case of 3G. Yes. So when a mobile node moves, the function of all handover, as we have seen in 3G network, it is taken care of this mobility management entity. So it provides the device authentication, device management, handover, yes, and the path setup from mobile device to the packet gateway. So this, it is the responsibility of the mobile management entity to choose a particular SGW and packet gateway. Say a particular equipment which is present or connected to this particular eNode B wants to communicate with the different server. Yes. So it is the responsibility of this mobile management entity to decide which is the SGW. Say it can choose this particular SGW and it can go along this router to this particular SGW and then this PGW and then to the server. So it is up to this mobility management entity to choose the SGW and PW. Next, we are going to see about the control plane and data plane functions. Yes. So, normal MAC layer functions, we divide it into different planes. So, similarly here, in case of LTE2, we do have a data plane and control plane as well. So the data plane will only take care of movement of data from the user equipment to the server or from the server to the particular user equipment. So how it is being done? From the user equipment to eNode B and eNode B to the selected SGW and from selected SGW to PGW and then to the server. So for this, the tunneling mechanism is there. Yes. So this tunneling mechanism, tunnel, it is a private connection, as we have seen in case of mobile IP. So through this the data will be transmitted. Now for the seamless transmission of this data from one user equipment through various routers and SGW and PGW to server, we need so much of other control information to be transmitted. That is, as we have seen in previous architecture diagram, the user equipment cannot directly communicate with the distant server. Instead, it has to first communicate with this base station. It has to authenticate itself. Then the base station will have to communicate with the mobility management entity to see where the device is registered, what is the home location of the user equipment, what is the new location of the visitor location of the user equipment, and then it has to communicate those information to SGW and PGW so that the data is routed accordingly. So all this extra information, it is called as control information, and that is called as a control plane. So it has basically got two planes. One is the data plane and the next one is the control plane. As we had seen about 4G, let's also see how different is 5G. So 5G, it supports new radio. Even 4G, it supports software defined radio. So here in 5G it uses two different frequency band, and one of it is millimeter wave frequency. You know, millimeter wave frequency, it operates within a very short range but provides very high data rate. So the size of the cell, you can see it is from 10 to 100 meters, but the data rate is huge. So here it uses MIMO antenna, the OFDM OFDM access method, and this is all the reason why 5G is lot better than 4G. Now let's see what are all the challenges which are present in 4G network. It is integrating all the services. As we have seen, different type of data services must be integrated, and you need to migrate from 3G to 4G framework. Though we have minor differences in the name of the terminology, as such the interface is the major difference. So the interface is communication between one equipment to another equipment. It has been totally changed. So that's why they have changed the name of the component too, because it is no more the same as that of the 3G network, because every interface there is a software or hardware technology used which is completely different when compared to that of the 3G network. So 4G network, it provides high data rate services and low per bit transmission cost. So it has to meet the demand of various users. Some may prefer 3G, some may prefer 4G, and now already 5G has evolved. So nobody will be willing to shift to 4G because they would always love to move to 5G. So setting up a new infrastructure, making new configuration, everything is a challenge. So let's believe that 5G will solve all problems. Still 5G has got certain challenges, but still it has got very high data rate, and hence probably 5G will be the competitor for the 4G. And thank you for listening.